Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Department of Mechanical Engineering, Dundigal, Hyderabad. Today we are going to study, the topic is steering gear mechanisms. The steering gear mechanism is used for changing the direction of two or more of the wheel axles with reference to the chassis in order to move the automobile in a desired path. These mechanisms are so important to avoid accidents. So there are various types of mechanisms are there. Before going to study those mechanisms, we have to know the condition for correct steering. After knowing the condition for correct steering, we'll study the Ackerman steering gear mechanism, Davis steering gear mechanism, Davis steering gear mechanisms. So very important, these are the mechanisms in order to avoid the accidents during the accidents caused by steering. So here usually the two back wheels have a common axis which is fixed in direction with the reference to the chassis and the steering. These things will be controlled by the means of front wheels. Now here it is a Ackerman steering gear mechanism, and it is a 4-bar steering gear mechanism. There are two are there. So it is the rear axle. How the Ackerman steering gear mechanism works. This is the rear axle. When you take the right turn and the wheels will be moved in the direction, and when you move in a left turn, the wheels will move towards the left direction. And due to the inclination of the steering, will automatically return to initial state after turning. When you are taking right turn, the instantaneous center will be located in this towards right direction. When it takes the left turn, the instantaneous direction will be in the left direction. So here this is the difference between 4-bar mechanisms and Ackerman steering gear mechanism. So these Ackerman steering gear mechanism, if you draw a line, it should be drawn, it should be intersect at the midpoint. Now when an automobile takes its turns on the road, all the wheels should make concentric circles to ensure that they roll on a road smoothly. And one more thing is that there is a line contact between the tires and the surface of the path, preventing the excess wear of tires. And very important is that the contact between the wheel tire and the surface is a point contact. It is a point contact. And when the contact between the two things is a point contact, then it is called as higher pair. It is known as a higher pair. Now this contact will be achieved by mounting the two front axles on two short axles. Those are known as a stub axles. So the stub axles are a pin jointed stub axles with the main front axle which is rigidly attached to the rear axle. So in that manner, the steering is affected by the use of the front wheels only. So there is a contact. The connection between joint is pin jointed. Okay, and the stub axle, the front wheel is the front axle which is rigidly attached to the rear axle. That's why When the front axle moves left turn or right turn, it will affects the rear wheels. So it affects the use of the front wheels and attached to the rear wheel. So this front wheels affects the rear wheels. So very important here, the term is called stub axle. What is the meaning of stub axles? In order to move the contact between, there is a contact between the tires and the surface of the path, and it in order to preventing the excess wear of the tires. This can be achieved by mounting the two front axles on two short axles known as stub axles. The short axles are known as a stub axle. We can see in this how the eye center is when it is taking the right turn. Now, when the axle is moving turn towards one side, that is in right side, the front of wheel of that side must swing about the pin through the greater angle than the wheel of the other side. The ideal relation between the swings, of the two wheels would be if the axis of the stub axles, this is the stub axle portion. Okay, this is the stub axles. When produced intersect at a point I, you can see this is the produced, it intersects at a point A. This stub axles produced and it will intersect the rear axle shaft at point I. This point I is known as eye center. Okay, this is the common eye center. It is common to the front wheels and the rear wheels. Okay, in that case, all the wheels of the vehicle will move about a vertical axis, that is I. The vertical axis I, minimizing the tendency of the wheels to skid. It is very important in order to avoid the skidding of the vehicle. The extension of the front axles, stub axles, and the rear wheels axle shaft should intersect about point I. So in order to avoid the skidding, in order to minimize the tendency of the wheels to skid, when the vehicle is moving, when you are taking a left turn or a right turn, here in the condition is that it is a right turn. When the right turn, it should be maintain the rear axle. Okay, then in order to avoid the tendency, minimizing the tendency of the skidding. So this I is known as eye center or instantaneous center of rotation. Okay, what is instantaneous center of rotation? What is the eye center? It's very simple example. The eye center means when there is a relative motion among the two links, one of the link rotates about another link, about a center. That center is known as eye center. Suppose if we consider a finger, the finger can move, very simple, it moves about the palm, about this point. That point is known as eye center of that finger. Similarly, we have like that all. How many eye centers we have on this hand? There are 5 eye centers are there. That is a simple example. That's why we consider there are various types of eye centers are there. Number 1, fixed eye center. Another one is permanent eye center. And third one is neither fixed nor permanent eye centers. Those types of eye centers, the topic was already discussed in previous sessions. Now, what is the condition for correct steering? Here in this figure, you can understand that stub axle of the point, there are PQRS is the chassis having stub axle at point P and it attaches Q. The width of the track is W and SR. It is the distance between the wheels is A. Now here, the stub axle of P is making an angle with phi with the eye center, and Q is making an angle with theta. Now, according to concepts of geometry, this angle theta is same as This is same as theta, this one. It should be, this is theta. And this angle is same as phi. Okay. Now, cot phi equal to, what is the cot phi equal to? The cot phi equal to this theta and phi are the angles turned by stub axles. And L is the, what is the L is the wheel base, and W is the distance between the pivots of the front axles. This is the distance between of the front axles. Now, from triangle, there are two types of triangles are there. What is the cot phi here? The cot phi is the there is a triangle. The right angle triangle is TPI. That is one of the right angle triangle. Another right angle triangle is TQI. From the first TPI triangle, cot phi equal to, what is the cot phi equal to? PT by horizontal side upon opposite side. That is TI. PT by TI. Then cot theta equal to, what is the cot theta? From right angle triangle of TQI, cot theta equal to QT by TI. Now, cot phi minus cot theta. Cot phi minus cot theta equal to PT by TI minus Q2 by TI. Now it is nothing but PT minus QT by, is the same LCM TI. Now PT minus QT, what is the difference between PT minus QT? Substitute PT minus QT, that is PQ. That is PQ by TI. What is the PQ? The distance between P and Q is W. What is a TI? It is L. So cot phi minus cot theta equal to W by L. So this is known as the fundamental equation of correct steering, and also known as condition for correct steering. This is also known as condition for correct steering. So this equation, whenever we are going to design any steering gear mechanism, that mechanism should fulfill this equation. This is the fundamental law of equation, fundamental equation of correct steering, or condition for correct steering. Okay, is a very important equation in order to design and analysis of any steering gear mechanisms. Now, that is cot phi minus cot theta equal to W by L. That is a ratio. What the angles between stub, the difference between stub axles equal to the ratio of W, distance between two pivots point, two front wheel, that is W by L, that is the wheel base. That should be satisfied. Okay, this is the condition for correct steering. So they will ask you what is the angles between, what is the ratio of the wheel base, wheel distance between W and the wheel base. Based on the data, they will give you while solving the problems. Now there are various types of mechanisms are there. One of the mechanism is Davis steering gear mechanism. The Davis steering gear mechanism, this is the Davis steering gear mechanism. Okay, it is an exact steering gear mechanism where this is the P, this I is the I center. So, and this is the back axle and it is the front axle. It is an exact steering gear mechanism, and the slotted links are there. There are two types of slotted links here. One is A and M, AM, and another one is B with respect to H, BH. These two are attached to front wheel axle, to the front wheel axle. These front wheel axle which turn on pivots point A and point B. Next, there is a rod is there. The rod is CD, is the rod. This is the C and it is D. This CD is the rod. This rod moves, constrained to move in the direction of its length. It has to constrain to move in this direction of its length, in a longitudinal direction, not in transverse direction. It should move in a constrained in a longitudinal direction. By the sliding members, there are two sliding members are there at P and Q. There are two sliding members at P and Q. These are the sliding members. This is P and Q. So that it can be constrained. So constrained is a completely constrained motion. In a completely constrained motion, so that it will be constrained along the length. It will not go away from it won't be derailed from that slot. That's it. There's the P and Q. These constraints, that P and Q, are connected to the slotted link. Connected to slotted link AM and BH by a sliding and turning pair at each end. The steering is affected by moving. The steering will be affected by moving CD to the right and left of its normal position. It will move in the left and right of its normal position. So the new position is C dash D dash, shows the new position of the CD. So when it moves from C to D, it is the position, initial position. Then it is moving from CD position to C dash, D dash and C dash. These are the new positions. When it makes the new position, the angle turned by, that is the angle phi and angle theta. So these are the angles. Okay, these are alpha, okay, theta. So angle phi and angle theta from the position alpha to, this is alpha, there is already, but theta and phi after moving the new positions. So this is the left turn. Here we are considering the left turn motion. There are certain notations are there in this. The notations are the where A, what is the position of A? This is the A. This A is vertical distance between the axles AB and CD. And B is the wheel base. In condition for correct steering, this is B. In the place of B, there is a letter L is there. L is the wheel base. Now here it is B. And C is the distance between point A and front wheel axle A and B. Now pivots A and B. And there is another letter is called X. This X is the distance moved. Very carefully see here. Distance moved by AC to AC dash and BH to BD dash. AC to AC dash, that equal to CC dash to DD dash. And there is an angle. That angle is called alpha. This alpha is the inclination of the links AC and BD to the vertical. Now there is triangles are there. From triangle A dash, from A dash and C dash. Where is the triangle? This is the triangle. Very carefully if you see it here. A dash and C dash. This is the triangle. And what is the tan alpha plus phi? The tan alpha plus phi equal to opposite side by adjacent side. The opposite side is A dash C dash and adjacent side is A dash. Now this A dash C dash, the sum of, what is the term? The sum of, it is a D plus X by, what is A dash? This A dash is A. That is the term tan alpha plus phi. Now here, coming position here. Now again we'll use it here, tan alpha minus theta. This position comes, total is alpha and minus theta. Tan alpha minus theta, we'll use it. Now from triangle again, A dash C, there is one more term, we can go for it. Tan alpha, this is A dash C. From this triangle, tan alpha equal to A dash C by A dash. What is A dash C? A dash C is D. By A dash is A. Next, from triangle, now this portion is what? Our right side portion was completed. This portion was completed. Now coming to left side portion. Now we have to focus on the left side portion. This is the portion we'll consider. Now by considering that portion again, what are the angles are there here? Tan alpha minus theta. This is the total tan alpha minus theta. The angle, this is the triangle. What is the tan alpha minus theta is? Tan alpha minus theta equal to B dash D dash by B dash. What is a B dash D dash? This the total is D, okay, D minus X. B dash, what is the B dash is A. So tan alpha plus phi, we got one value. There are we have values tan alpha plus phi, tan alpha and tan alpha minus theta. Then we know that tan alpha plus phi equal to tan alpha plus tan phi by 1 minus tan alpha tan phi. We know that tan alpha plus phi, substitute those values into this equation, then d plus x by a equal to tan alpha we got, that is d by a plus tan phi by 1 minus d by a times tan phi. The final answer becomes d plus a tan phi by a minus d tan phi. Now if you do cross multiplication with d plus x by a, then d plus x into a minus d tan phi equal to a into d plus a tan phi. Finally, after simplification, we can know it from this simplification unknown. The value is tan phi. This tan phi equal to ax by a square plus d square plus dx. Now, next tan alpha minus theta. There, what is the unknown value comes? So tan theta we will find out. Let me find out here. Tan alpha minus theta equal to, substitute again. Tan alpha minus theta equal to tan alpha minus tan theta by 1 plus tan alpha tan theta. Substitute here tan alpha minus theta. We got to know tan alpha minus theta is d minus x by a. That is d minus x by a. What is the tan alpha? D by a minus tan theta by 1 plus d by a tan theta. After following the same procedure and simplifying, we can know the value, that is tan theta. The tan theta equal to ax by a square plus d square minus dx. Why we are doing all these values? Because we are going to substitute. We know the condition for correct steering. What is that? Cot theta minus cot phi minus cot theta equal to, from that condition, W by L. What is the W here? It is the C. What is the L here? It is the B. C by B. In the place of what is the cot phi means? 1 by tan phi minus 1 by tan theta. That equal to C by B. What is the tan phi? Just now we achieved here tan phi equal to ax by a square plus d square plus dx. What is the tan theta? Ax by a square plus d square minus dx. Now, substitute these two values in the condition for correct steering. Okay, there, then we can know the simplifying. Now substitute here 1 by tan phi minus 1 by tan theta equal to C by B. Again, that is tan phi a square plus d square plus dx by x minus a square plus d square minus dx by x equal to C by B. Now ax is the common. After making simplification, then minus a square minus d square will be cancelled. Then it becomes what? 2 times dx by ax. 2 dx by ax equal to c by b. Now x cancelled. 2d by a equal to c by b. Now what is the d by a? That is tan alpha. 2 times tan alpha equal to c by b. Now tan alpha equal to c by 2b. The angle turned by the front wheel in order to avoid skidding of the vehicles. The ratio, that angle is equal to a ratio between C is the center of the two pivots A and B and the wheelbase, that is tan alpha must be equal to C by 2B. Then only that angle, otherwise the vehicle will be skidded or skidding. Vehicle skidding takes place. So it's very important in order to design the steering in order to avoid skidding of the vehicles by using steering. Generally accidents taking place because of there are one thing because accidents takes place improper driving or improper steering. The main cause is that this is the way when this condition is not fulfilled, then skidding takes place. The topsy-turvy, the upside down of the vehicles we can observe on the highways. So generally it will happen mainly during night time. There is a maximum more chances are there in order to this taking place, skidding takes place. Vehicles is skidding during steering. So these are the two conditions. Very important mechanism here it is. One more thing is that here, though the gear is theoretically correct, but main thing is that why this steering gear, Davis steering gear mechanism is outdated nowadays. Why? Because there are more sliding members are there, and the wear, because of the sliding, the contact between this PQ and the axle, front axle is a surface contact. Because of that surface contact and sliding contact, more friction takes place. When there is more friction, there will be more wear and tear takes place. And the wear will be increased, which produce the slackness between the sliding surfaces. So, thus eliminating the original accuracy. Hence, this gearing, this Davis steering gear is not in common use. It is outdated. It is not in common use. But we learned the principles how to avoid skidding from this Davis steering gear mechanism. We can know the principle of or the condition of skidding. What is the condition for skidding? Tan alpha should be equal to the ratio of the two pivots C by 2B, 2 times the wheelbase. Okay, this is the conditions we have learned. In this class. Again, very important, the concept is required in order to learn or in order to do design various steering gear mechanisms. The principles are the principle of that is Arnold-Kennedy's theorem or I-Centers theorem or three-centers inline theorem. And one more thing is very important is that condition for correct steering. And condition for correct steering is so important in order to avoid the wheels skidding or vehicle skidding. Okay, and we have studied in this class what is the Davis steering gear mechanism. There is one more steering gear that is called Ackerman steering gear mechanism. So before going to solve this Ackerman steering gear mechanism, this Ackerman steering gear mechanism is a very simple mechanism. It is also important in order to avoid or in order to maintain the correct steering and also to avoid the skidding of the vehicles. Now let us come to the solve how the Davis steering gear mechanism is important and what is the angle, steering angle is required to avoid skidding. So here in a Davis steering gear, the distance between the pivots of the front axle that is a C equal to 1.2 meters, and the wheelbase this is the C, and the wheelbase, this is the wheelbase, that is a B. They have given 2 points. The wheelbase is 2.7 meters, B equal to 2.7 meters, and find the inclination of the track arm on the longitudinal arm to the longitudinal axis of the car when it is moving along a straight path. When it is moving along the straight path, what is the inclination of the track arm? How much track arm should be inclined? What is the track arm should be inclination? This is the inclination of track arm, that is alpha. That alpha equal to, we know the formula, that is tan alpha equal to C by 2B. Substitute those values of C and B in this equation or in this formula. That's tan alpha equal to C by 2B, where C is 1.2 meters and B is 2.7 meters. That is 1.2 by 2 times 2.7, then 0.22. Then what is the angle? Alpha equal to tan inverse of 0.22, that equal to 12.5 degrees. So this is the angle. One more important is that this is the inclination of the track arm to the longitudinal axis of the car. Okay, when it is moving, that angle should be there. That is 12.5 degrees. Okay, this is the class. In this class, we studied what is the condition for correct steering and what is Davis steering gear mechanism. And one more thing is that how the Davis steering gear mechanism has limitations, such a way that that steering gear mechanism is outdated right now, and how to find out the inclination of the track, inclination of the track arm with to the longitudinal axis of the car we found. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.